Alright, welcome back to question 3 for the 2020 topic test. So getting back into it, so differentiate y equals to 4 over x minus 3x squared plus 5 over x squared. For this question, I prefer to just use the power rule. How we use the power rule is by moving the x to the numerator and becomes x to the power of negative power. So the power becomes negative. So therefore y equals to 4x to the power of negative 1 minus 3x squared plus 5x power of negative 2. So now applying the power rule, so therefore it becomes negative 4x to the power of negative 2 minus 6x minus 10 to x to the power of negative 3. Alright, so that's just an achieved question here. So this is achieved, and you actually don't need to simplify this question, because for question A, for every test paper, it just says you do not have to simplify your answer. So therefore, you can just leave your answer like this. Okay. So question B: if y equals to ln of kx minus 1 plus 3x, and the gradient of tangent at x equals to 2 is 5, we should find k. To differentiate the ln, we need to use the chain rule. The derivative of the inner function is just k, so the derivative of the inner function multiplied by the derivative of ln. The derivative of ln is just 1 over everything inside the ln function, so it becomes 1 over kx minus 1 times of k. So therefore, dy over dx that equals to k divided by kx minus 1. And don't forget our plus 3x, that becomes just plus 3. The gradient of the tangent at x equals to 2 is 5, so we just plug in our 5 equals to k divided by 2k minus 1 plus 3. Rearranging the equation, we get 2 equals to k divided by 2k minus 1. And therefore, 4k minus 2 equals to k. Therefore, 3k equals to 2, and therefore k equals to 2 over 3. And that should be our final answer, and this is again just an achieved level question. Question C: a water slide is modeled by y equals to negative 1.4 sine of 0.4x minus 8 plus 0.06x plus 1.14. The water slide is considered safe if the steepest value is less than negative 0.5. Assuming the steepest value occurs at x equals to 3.4, determine whether the slide is safe or not. And so this question is actually, in terms of the logic behind it, is pretty straightforward. All you need to do is differentiate and then substitute x equals to 3.4, because you're trying to find the steepest gradient and you want to check if that's greater than or less than negative 0.5, and then you'll make your conclusion based on the calculation given. Okay, so we just need to differentiate this equation. So derivative of negative sign, that goes to negative cos. The sign doesn't change from sine to cos, so negative sign goes to negative cos, and we need to multiply by the derivative of the inner function. The derivative of the inner function is, as you can see, the inner function is 0.4x minus 8. The derivative of that is 0.4. So therefore, we need to multiply negative 1.4 by 0.4. Okay. So therefore, dy over dx that equals to negative 1.4 times 0.4 cos of 0.4x minus 8 plus of 0.06, and the 1.14 is a constant, it just disappears. Okay. So therefore, dy over dx that equals to negative 1.4 times 0.4, sorry, equals to negative 0.56 cos of 0.4x minus 8 plus 0.06. So now we need to check at x equals to 3.4, so dy over dx that equals to negative 0.56, sorry, cos of 3.4 times 0.4, 1.36 minus 8 plus 0.06. Alright, so once you evaluate this function, be very careful. Your calculator must be in radians, okay? So once you differentiate something, it has to be in radians, okay? Everything here in this calculus topic is in radians, unless you're calculating an angle, specifically in geometrically, okay? It only applies with degrees if it's a geometrical, okay? But in this case, we're going to be using radians, okay? So make sure your calculator is on radians, okay? Very important. So therefore, cos of times negative 0.46 plus 0.06. Alright, that actually gives us dy over dx equals to negative 0.4647. As you can see here, this is greater than negative 0.5. And it's only safe if it's less than negative 0.5. Therefore, this is not safe. Okay, so you can say negative 0.4647 is actually greater than negative 0.5. Therefore, slide not safe. And this is a merit level question, okay? If you can justify your answer with the criteria given, you can get a merit. To get an achieved, I think you can just differentiate the function that's an achieved. However, if you just leave, let's say you don't have this, let's say you're missing this statement here, then you can only get an achieved. The reason you can only get an achieved if you miss out the statement is because the question specifically asks you whether the slide is safe or not. By missing out the statement, you are actually not answering the question, and if you don't answer the question, you'll get marked down, okay? So remember, that's very important. You have to write the statement, or else you will get marked down 100% of the time, okay? So if the question asks you for something, you have to answer the question. So in this case, answer the question, say if the slide is safe or the slide is not safe, okay? Alright, so that should be the answer to that question. Question D. A balloon is rising vertically at a constant rate of 0.3 meters per second. A person filming the balloon stands 16 meters away from a spot directly below the balloon. What rate is the distance d from the person to a balloon increasing when the balloon is 20 meters away from the direct line? Alright, so let's say this point P is where the person is. Okay, we'll just say that. Okay, so once again, one of these rate of change questions, like I was saying in my previous video, first thing you do, write down what you have. Okay, so what you have, balloon rising vertically, so this h is increasing at 0.3 meters per second. Rate refers to time, remember, so dh over dt, that equals to 0.3, okay? What do you want to find? You want to find the change of distance d with respect to time, because it's rate, right? Rate refers to time. So therefore d over dt is what we're trying to find, and that could be equal to dh over dt multiplied by something. In this case, we want to get rid of dh, so we'll just add out a dh here in order to cancel it out. And we need to introduce a new variable, we need to introduce dd. So that's what we're trying to find. So now we need to find an equation that has only d and h in it, okay? So, and that automatically stands out to you that we can use Pythagoras, okay? Very easily we can use Pythagoras. 16 squared plus h squared equals to d squared, okay? 16 squared plus h squared equals to d squared. Therefore, d equals the square root of 16 squared plus h squared. Therefore, d equals the square root of 256 plus h squared, okay? Alright, so once you differentiate this, we're going to be using a chain rule. So again, we can't differentiate the square root, so we need to rewrite this as power of 1/2. Okay, so once we differentiate this, we'll get dd over dh. We'll take the 1/2 to the coefficient. 1/2 times of 256 plus h squared. Take the power down by 1, becomes negative 1 over 2, and multiply by the derivative of the inner function. So that becomes multiplied by 2h. Okay, so rearranging this equation to dd over dh, 1/2 times of 2h is just h, so h, and we know that the power to a negative can be rewritten as 1 over the power of a positive, okay? So we can rewrite this as square root of 256 plus h squared. Now we have dd over dh, that's what we're trying to find, we have that now. So now we can multiply by dh over dt in order to find out dd over dt. So dd over dt, that equals to 0.3 h divided by square root of 256 plus h squared. Right, so the question asks us to find the rate of change of d when the balloon is 20 meters away from a direct line. Okay, so the wording of this question can be a little bit misleading, especially by direct line, because technically direct line can really mean anything. That also is a direct line, so a little bit misleading. But in terms of the question is saying that the d value is 20, because when the balloon is 20 meters away from the direct line is that distance d. So trying to find the rate of change of the distance when we're trying to find the rate of change of d when d is 20, okay? So now all we need to do, because in this equation of dd over dt, we have it in terms of h, and we don't have h. So we actually need to find out h by using the Pythagoras theorem. So therefore 16 squared, we know 16 squared plus h squared, that equals to d squared. But in this case, d squared we know is 20. So that equals to 400. And therefore h squared equals to 144. H equals to plus or minus 12. But you know that h cannot be 12. So that's why negative 12. So therefore h equals to 12, okay? Therefore, dd over dt, that equals to 0.3 times of 12 divided by square root of 400. Alright, that gives us 0.18, and the unit is, because this is h is measured in meters, so this will be meters per second, because time was measured in seconds in this case, okay? So seconds and meters, okay? So that will be your unit. And this is a merit level question, okay? So getting up to here, that's a merit grade. To get an achieved grade, you can find your if you can find your DD over DH, perhaps that might get you an achieved, okay? Alright, so question E. A rectangle ABCD is formed so it is enclosed by the parabola y equals to x times of k minus x, the axis of symmetry line k over 2, and the x-axis as shown in the diagram. The vertex C is fixed to the parabola D, and is fixed to the parabola. D is fixed to the x-axis, and the side of the rectangle AB is fixed to the axis of symmetry. Show that the maximum area is root 3 k cubed divided by 36. For this question, okay, so first thing we want to write down here is what is the area of a rectangle. Okay, let's get the basics. Let's get the basics done first. Okay, so area equals to base times height. What is your base? Okay, so in your base we have a rectangle at k over 2, and we're going to move x units to the right, and that will be our base. Okay, so we're moving x units to the right, or we can look at it as k over 2. We can look at this distance as x. So this distance is x amount of distance away from the origin. So therefore we can say that k over 2 minus x is this side length here. Okay, so that will be our base. Okay, so our base is k over 2 minus x, and we know that the height, because it's touching the parabola, we know the height is simply just y. Okay, and y was defined as, given to us as x times of k minus x. Okay, so we know that area equals to k over 2 minus x times of what was it? So k x times of k minus x. So if we expand this, it becomes kx minus x squared. Okay, so that's kx minus x squared. Right, let's expand this out. So okay, so we get k squared x over 2 minus k x squared over 2 minus kx squared plus x to the power 3. Alright, so area equals to, let's simplify this a little bit, k squared x over 2 minus 3 over 2 kx squared plus x to the power 3. Alright, so now we need to differentiate with respect to x, because k is a constant, okay, and x is the one that's changing, because we're changing x whenever we move the rectangle. We're changing the x value. Okay, so dA over dx that equals to k squared over 2 minus 3kx plus 3x squared. And we know that at the maximum, dA over dx equals 0. So therefore 0 equals to k squared over 2 minus 3kx plus 3x squared. At this stage, okay, we have a quadratic formula. Okay, we need to have a quadratic. Okay, we need to use the quadratic formula. Okay, so negative b plus or minus square root of b squared minus 4ac over 2a. Okay, negative b, that's just 3k plus or minus square root of 9k squared minus 4 times of the a value would be k squared over 2. So k squared over 2 times of, sorry, that's not a, that's our c value. I apologize. Our a value is actually 3. And that's divided by 2a, which is 6, okay? So therefore this becomes 3k plus or minus square root of 9k minus 12 times of k squared over 2. That becomes 6k squared, so that's squared, divided by 6. So 3k plus or minus square root of 3k squared over 6. And therefore, if we simplify this, we get 3k over 6 plus or minus. If we take the square root, we can square root k, so square root of 3k over 6, okay? So therefore 1 over 2k plus or minus square root of 3 over 6k, okay? So that's our k values. So our k values are, so x equals to 1 over 2k plus or minus square root of 3 over 6k. Alright, so now what we need to do is we need to check these x values. We need to see if they're both greater than 0, okay? So if we check, let's say x equals to 1 over 2k plus square root of 3 over 6, that's obviously greater than 0, so it's it is a possible answer, okay? Because we know if x is negative, then it cannot be a possible answer, because our parabola was positive, okay? Was not positive, but our parabola was on the right hand side of the origin, okay? So know that the x value is positive here, okay? So x equals to 1 over 2k minus root 3 of 6k. We're going to check if that's greater than 0. Root 3 over 6, 0.5. So that is greater than 0, okay? So we know this is also greater than 0. So as you can see here, we have a little bit of a trouble here. So we have two different answers, and we actually need to determine which one is the minimum, which one is the maximum. Okay, so I know the question actually tells you that you don't need to show that if your area is a maximum, but in this case you have to, because like you need to show that which x value you are using, and you need to show that it is indeed a maximum, because you do not know which one to use. Okay, so you can't just guess in the exam. If you guess in the exam, you'll probably get it wrong. Okay, so finding our second derivative now. So we know that our derivative, what was our derivative? Our derivative was k squared over 2 minus 3kx plus 3k squared, okay? 3x squared. So k squared over 2 minus 3kx plus 3x squared. That was our dA over dx. d squared a over dx squared, that equals to negative 3k plus 6x, okay? 6x. Because use the power rule. So d squared a over dx squared will test sorry, why am I here? Sorry. Apologize. Okay, so let's start here. Let's start that again. So dA over dx equals to k squared over 2 minus 3kx plus 3x squared. d squared a, that equals to negative 3k plus 6x. Alright, so let's test this value first. Let's test x equals to 1/2 k plus root 3 over 6. Okay, so d squared a over dx squared, that equals to negative 3k plus 6 times of 1 over 2k plus root 3 over 6k. Alright, so negative 3k and positive 3k cancel out. So therefore, what you're left with is d squared a over dx squared, that equals to root 3k. We know that k is definitely greater than 0, okay? So we know because k is greater than 0, then this is going to be the minimum turning point, okay? Okay? And we also know d squared a over dx squared, okay? Let's try the other turning point. So negative 3k plus 6 times of 1 over 2k minus root 36k. Once again, negative 3k and 3k cancel out. So we'll get negative square root of 3 over 6k. And this is negative, so therefore this is a maximum, okay? So now we know that this value here is the maximum, so that's 1 over 2k minus root 3 over 6k. So let's simplify this a little bit more. So we can say 1/2 minus root 3 6 times of k. And we can say this is 3 over 6 minus root 3 over 6 times of k. Therefore, this equals to 3 minus root 3 over 6k, okay? Now we need to substitute back into our area formula. Our area formula, what was our area formula? Our area formula was this. Our area formula was this. So k squared x over 2. Okay, so k squared x over 2. So substitute this one. That equals to k squared x over 2. So I can't remember. So k squared x over 2 minus 3 over 2 kx squared minus 3 over 2 kx squared. And we have plus x power 3. Okay, that is our function. Alright, so we need to substitute this k value as x and find our maximum area. So 3 over 6k, that equals to k squared times of 3 minus root 3 over 6k divided by 2. Alright, and minus 3 over 2k x squared. Okay, so now we need to do a little bit of algebra here. Okay, so we know that 3 minus root 3 over 6 times 3 minus root 3 over 6, okay? So that gives us 9. 9 plus 3 minus 6 root 3 over 6, that equals to 12 minus 6 root 3 over 6, that equals to 2 minus root 3, okay? That actually makes our life a lot easier, okay? 2 minus root 3, so therefore this is 2 minus root 3k squared. Sorry, k squared, because we already squared the radical, okay. Plus of, so now we need to do 3 minus root 3 over 6 cubed, okay, so now we need to do 2 minus root 3 times of 3 minus root 3 over 6. That will give us 6 times 6 plus 3. 6 plus 3, oh, far out. Okay. 6 plus 3 minus 2 root 3 minus 3 root 3 minus 5 root 3 over 6. Okay. Okay, so that equals to 9 minus 5 root 3 over 6. Right? Hold up. So 12 minus... Oh, sorry. Yes, I did forget. So this is actually 6 times 6 is 36. I forgot to multiply the denominator. So that becomes that over 6. So this is actually 36. So apologize. Okay. Yeah, that equals to 9 minus 5 root 3 over 36. So therefore, this is 9 minus 5 root 3 over 36. And don't forget the k squared. Sorry, not k squared. Don't forget the k cubed, because we need to add that one. Okay. So a of 3 minus root 3 over 6k, that equals to k squared. So k squared times with k, that's k cubed. So now we have 3 minus root 3 over 6. We can actually move that 6 to the denominator because we're dividing by 6. So we can move that 6 to the denominator. We can say that this is 3 minus root 3 k cubed divided by 12 minus 3 over 2 times, so k times k squared is k cubed, so times 2 minus root 3 k cubed plus of 9 minus 5 root 3 over 36 k cubed. Alright, so we can simplify this even further. Okay, so 3 minus 3 root 3 k cubed divided by 12 and we had, okay, so 3 over 2 times everything, so we have okay, minus, sorry guys, I need to keep transitioning. So 6 minus 3 root 6, so 6 minus 3 6, oh, I keep forgetting. Okay, minus 3 root 3, okay, so minus 3 root 3, okay, here we go, divided by 2, okay? Right, looks like it, yeah. Okay. Squared. Alright, and don't forget the 9 minus 5 root 3 over 36. So minus 9 plus 9 minus 5. Okay, plus 9 minus 5 root 3 over 36. Okay, so that's our area. So now we need to make everything a common denominator. We can see the lowest common multiple is 36. So multiply this first fraction by 3. So 9 minus 3 root 3 k cubed over 36. Multiply the second one by 18 actually. So alright, I think why is it only 2 denominator? So 2 3 over 2k squared. Right, we forgot about the over 6 actually, because remember we had that over 6, we totally forgot about that one. So this is over 6, and therefore this is actually over 12 as well. Okay, so my apologies once again. Okay, so this is over 12, multiply this fraction by 3 as well. So minus 18 minus 9 root 3, don't forget the brackets here, so divided by 36, plus 9 minus 5 root 3 over 36, okay? So now we can add the like terms, so we have 9 minus 18 is negative 9, negative 9 plus 9, that's 0, so cancels out. So 9, negative 18, 9 cancel out. So now you have negative 3 root 3, plus a negative, and the negative makes a plus, negative 3 root 3 plus 9 root 3, that is 6 root 3, 6 root 3 minus 5 root 3, that is, so I forgot the k cubed here, 6 root 3 minus 5 root 3, that is just root 3, and everything over 36, okay? So therefore, a equals to 3 root 3 k cubed over 36, and this is what they required, so this is your final answer. If you can get up to your final answer here, that's an excellent grade. Okay, very tough question. Okay, lots of very algebra demanding question. To get a merit grade, okay, so get a merit grade, if you can find your maximum turning point, so this is your maximum turning point here, that will get you a merit grade. To get an achieved grade, okay, achieved grade, achieved grade, achieved grade could just be differentiating up to here, okay? Differentiating up to here could just be an achieved. Right, yeah, so this is a very challenging question. A lot of algebra is involved in this question. To be honest, I think it was more algebra than calculus, but don't quote me on that, okay? So thank you for watching this video. I hope you enjoyed watching this video. I hope you enjoyed, and if you liked the video, please drop a like, and I hope to see you all